Okay, now that we've learned all that information that we learned in the last lesson about the 4 quantum numbers of an electron, we can actually use that information to do what's called electron configurations. So showing the location of these electrons in a really quick representative way. So these are drawing out those Bohr models that we were talking about, okay? So as we do this, a couple of things we need to remember. We gotta remember a couple of rules for how to draw these out. Okay, so the first rule is known as the Pauli exclusion principle, and this is that each orbital can only hold 2 total electrons, and they have to be spinning in opposite directions. Okay, we talked about that in the last lecture, that each orbital holds 2 electrons. They have to spin in opposite directions. So one has an upward spin, one has a downward spin. Okay, the next is called the Aufbau Principle, and this is that electrons fill the lowest energy orbitals first. Okay, lowest energy comes first because as you work your way up, it requires more energy. And so think about this as they're lazy. Okay, the electrons are lazy, so they want to have the least amount of energy possible. Okay, it's also kind of called the lazy tenant rule, right? If you have a 5-story building and there's no elevator, everybody wants to live on the first floor, right? They don't want to have to carry their stuff up to those higher levels. They don't want to have to climb the stairs every single time they want to take their dog to go out to the bathroom or to go to the grocery store. So everybody wants to live on the first floor. Well, you've completely filled the first floor. There's no open apartments on the first floor anymore. Okay, fine. Second choice, fine. I want to live on the second floor then. I do not want to carry up that many flights of stairs, right? So same idea with these electrons. They want to go to that lowest level first. When the lowest level is full, then they move to the next energy level or the second floor, and so on. Okay, the next rule is called Hund's rule. That is, within a sublevel, you will place 1 electron per orbital before you pair them. Okay, they prefer to be alone rather than in pairs. So if you have an empty orbital, you put it in there first. Then, when there's no more empty ones, then you can start pairing. This is also known as the empty bus seat rule, right? When you get on a bus and you have an empty seat next to you, and then there's all these other empty seats, and somebody comes and sits down right next to you, you're not too happy, right? You're like, bro, really? Look at all them other seats. Go sit in one of them, right? You don't want to have to sit together. So here's 2 examples here. Okay, this first one is wrong, okay, because there's that empty sublevel right here, this empty orbital, okay? These 2 wouldn't have sat together, they would have sat separately, okay? So this one is correct. They each went to an empty orbital first, then we still had 1 more electron to place. There wasn't a place where it could go, so we had to pair it up in that lowest level one, okay? All right, last general rule, how many orbitals are there per sublevel? Okay, well, whenever you have an S, there is only 1 orbital, okay? But the P sublevel has 3 orbitals, because remember those orbitals is the direction in which it is, what plane is it on? Okay, so P has 3, the D has 5 orbitals, and F has 7. Okay, always. This is not something that changes. So as we get ready to draw these out, just remember, S has 1, P has 3, D has 5, and F has 7, always. So make a special note of that in your notebook. Okay. Let's start using this stuff. How can we use it? Well, first off, the good news is your periodic table is incredibly helpful to you. The periodic table basically tells you what to do. So go ahead and get out your periodic table. Hopefully you printed that out like I asked you to do. And that way you can be looking at it as I go through some of these examples. Okay, so the periodic table I provided you already has the S, the P, the D, and the F labeled. Okay, so S is the first two columns or families, including helium. He's a little odd, but he's over there, right? He is in helium, He. Okay, the P is this whole block right here. The D's are those transition metals, and F are the inner transition metals. Okay, now remember for the D, as is written on the one I gave you, it's N minus 1. So even though this is on period 4, it's on row 4, it's N minus 1. So for the D's, it's actually 3. Okay, and same thing, 5, it's actually 4D, 6 is 5D. And then for the F, it's N minus 2. So even though this one's in period 6, it's N minus 2. So 6 minus 2 is 4F, and this one is 5F. Okay, so you do got to remember you have to subtract that number. But we write them in the order they go, right? The lowest energy. So we just follow the periodic table. Let me show you what I mean. Okay, just a reminder, the period number is that very first number that goes. It shows you your energy level. Subtract that for the D and the F. Okay, so let's take a look at hydrogen. Okay, so find hydrogen on your periodic table. It's the very first element. Okay, so for hydrogen, it is 1s1. Okay, the 1 is the period that it's on. Okay, it's in the first period, first row. The S tells you that sublevel, so is it S, P, D, or F? It's S. And then 1 is the first column of S block. So there's only one electron in there, right? And that makes sense for for hydrogen, because hydrogen in a neutral atom, it has one proton. That's the atomic number 1. And that means to be neutral, it has one electron. So we just represented the one electron right there. Okay? But that was an easy one. That's the very first one, right? Let's do something a little more difficult. Okay, let's start with the orbital diagram for oxygen. So go ahead and on your periodic table, find oxygen. Its atomic number is 8, so it has 8 protons. Right now we're doing neutral atoms. That means it has 8 electrons. So I wrote down here we have 8 electrons. Okay, so we need to draw out these 8 electrons in an orbital diagram. Okay, so what I suggest doing is start with hydrogen number 1 and go, okay, so that block represents an S, and it's 1s, and then there's 1 electron. Okay, but we have more, and there's not another sublevel here, so 2. Okay, that represents helium. Okay, now I got to keep going. I haven't gotten to oxygen yet, so let's go to period 2, and we start with 2s, which has lithium and beryllium. And so there's 2 more electrons. So 1 and 2. Okay, but we haven't gotten to oxygen yet. We got to keep going. So what comes next? We're still on period 2, but now we're moving over to the P. Okay, so now we have 2p. And remember what I said just a minute ago about the rules. P has 3 orbitals. Okay, there we go. 1, 2, 3. Okay. All right, now let's draw in the electrons we have left. I've already drawn 1, 2, 3, 4. Now we'll draw number 5. Number 5. Okay, let's draw number 6. If we're following along on the periodic table, that got us to carbon. Okay, then 7, that gets us to nitrogen. Notice how my arrows I draw, the arrows represent the electrons. Notice that I put 1 in each one of my boxes, right? That's the empty seat rule. They don't want to be together, so they each got one by themselves. But I'm not to oxygen yet. I haven't drawn 8 electrons yet. I need 1 more, 8. Okay, this is the orbital diagram for oxygen. Okay, that's the orbital diagram. Now let's take this a step further and let's do an electron configuration, because scientists rarely draw them out like this, represented in arrows. Normally they do what's called an electron configuration, which is very similar but without the arrows. Okay, so this is an electron configuration. 1s2, and you just write a little 2 instead of drawing out the arrows. Then 2s2, again, same as this, but instead of drawing the arrows, you represent it as a superscript, and then 2p4. So this represents that there is 2 electrons in the s of level 1, 2 electrons in the s of level 2, 4 electrons in the p of level 2. Okay, and they go in this order. You just follow the periodic table. You just go box to box to box. You just follow along. Okay, so the longhand configuration was what I just showed you. But let's do another example. Let's do one a little bit further down, so it's going to be a little bit longer. Okay, we're going to do sulfur. So look on your periodic table and find sulfur. Okay, we see that it is atomic number 16. That's 16 protons. That means we're going to have 16 electrons. So how are we going to draw this out? Well, let's do what your periodic table tells you to do. Start up with hydrogen and count the boxes to go with you, okay? So we know we need to get all the way to 16. So we start with 1s, and it's going to have 2 electrons in it. Okay, keep going. Now we're at the second period, lithium and beryllium again. We're going to bypass those because we got to get all the way to sulfur. But this is 2s, and it's full. Okay, what comes next? Follow across. You get to boron. That's 2p, and we need 1, 2, 3, 4, 5, 6. Okay, we need all of those. So we're going to fill it into 6. All right, use your finger. Keep following along. Period 3 starts with sodium and magnesium. We still haven't gotten to sulfur, so we need this one too. So this is going to be 3s2. Okay, keep going. We go across. We get to aluminum, and we got to keep going. So now we're in 3p, but we're going to only go to sulfur. So if we're counting the boxes on the periodic table, that's 1, 2, 3, 4. 3p4. Okay, that's the longhand. That can get to be a lot if you're doing something further down on the chart, right? So we can do a shorthand. But what this is showing here, we have the valence electrons. So these are the ones on the outer layer. And then we have the core electrons. They are deeper within. Okay, let's do shorthand. Shorthand so we don't have to write so much when we get down to the bigger ones. To do this, what you're going to do is you're going to find what you need to do on the periodic table. You're going to go up one period and then all the way to the end to find the noble gas. Okay, and for sulfur, the noble gas is neon. And then you only write what is left after the neon. Okay? So the periodic table is going to help us again. Okay, so like I said, go up one row over to the noble gas, and then you just draw out the valence electrons. So the ones that are on the next row to fill it out. Okay, here's an example. Let's do germanium. The white box on here represents germanium. So we're going to go up one and over to the noble gas. The noble gas that is highlighted in white is argon. So we just write argon. And then we use the periodic table just like we've been doing to fill in the rest. So what comes after argon? Next is 4s, and both of those, so I'm going to write 4s2. Okay, follow the periodic table. What comes next? It's D. But remember, D is n minus 1. So we're on period 4, but we have to subtract 1. Okay, so this is going to be 3D, and then we're going to count them. There's 10, 3D10. Okay, then go to the next box. This is our P's. Okay, 4, so 4P, and then I need 1, 2. 4p2 to get me where I was. Okay, so that's how you do the shorthand. You use that noble gas to represent everything that comes before it. Okay? Stability, a full energy level, a full sublevel, and a half full sublevel. These are where atoms are stable. This means that at this point, it's hard to take away electrons when they are stable.